Hello, everybody. Welcome to SRA 365. I'm, of course, Professor S, and this is this week's lecture. So this week, notice that we are not in the slides. We are beginning with something else. The idea is like we are beginning with the Mosaic plot. What we're doing is we're combining the information that's provided from a chi-square test and kind of presenting it in the usefulness and efficiency of a graph. That's what a Mosaic plot does. So let's kind of just get into it. We're going to use the same data frame that the book provides, and that's this cat-dog thing. I'm going to call it cat-dog, but let's kind of take a look at what it is. It's observing cats and dogs, the type of training that they received, and if they can dance or not. Okay? And so kind of different than what the books use or the text is using, we're going to be comparing dog or the animal and if they can dance. Why not? Right? And so in order to use a Mosaic plot, we need a couple of things, but the first thing is to prepare the data to be graphed. And in order to do that, we need to have a contingency table. And we've talked about contingency tables before. I gave you some options before, and I'm going to give you one more. So last time, the table function was how we created our contingency table. Or one of the ways that we can create a contingency table, and that's what we can use this week as well, and I'll go through that second. The first thing that we're going to use is the X tabs, which is something that the text introduced this week, and then it's actually something that we need to use next week. So I'll be going through both, and there's like some added benefits to using X tabs over the table function for this, but I mean, really the added benefit is that, or of table, using the table function, is that we've gone through it before. Hopefully you've done it before. Otherwise, if not, welcome to X tabs. But anyways, let's kind of show what the two do as the contingency table. So X tabs, and the idea is with X tabs we need two arguments. First of all, getting the data, like the variables that we're referencing, and then citing the data. That you may say, wow, this is very similar to the linear models or the simple regression that we've done before. And you are correct, because we have to use a formula for this. Remember, we use the tilde, and then we say what after the tilde, we have the different things that are our predictors, right? And then the other side of that tilde is the response. Now, the idea is like we're not trying to find a response with our chi-square data. It's always just finding the relationship between the different variables. So we're just going to be looking at predictors. So in this case, it's animal and it is dance. And then we have to cite the the data that we're using, which is cat dog. And then when we run it, there's our contingency table. Notice it says like cat, dog, animal, and then dance, no or yes. Great. And then the table function, what we do is we take the columns and we put them into the table function. So in this case, we say the cat, dog, referring to animal, and then cat, dog, referring to dance. And then when we run it, gives us a very similar table. It's the same x's, like so the columns are referring to dance, rows are referring to the animal. It doesn't label them, but we can identify them now. A reason why we might like the labels is if our variables have the same possible values, right? So if we're comparing two different things that have yes and no as the two different options, so yes or no's for the columns, yes or no's for the rows, and we're pairing those together, that's going to be an issue, and we might really like the labels. Otherwise, like in this case, it doesn't hurt. So in this case, it kind of makes more sense to use the X tabs. And so what I'm going to do is I'm going to store these as observations, because I'll be using, we'll run both of these through both of the things. So, and you'll see what I'm saying with both the things. I know it's ambiguous, but So with chi-square test, well, here, we'll just run it with the observation 1. I'm storing it. Let me just run this. So here we go. So notice chi-square is 21.356. Degrees of freedom is 1. P-value is 3.815 times 10 to the negative 6. And then when we change this to the one that we made with the table, I keep running that and changing the value. Notice that it's 3.815 times 10 to the negative 6. Okay, notice our observation values right here. We have the X tabs for observation 1s and table for the other one. That's because they're creating different objects. So they're going to give different information, but it's not going to affect the chi-square test. Chi-square test is going to be the same. It's going to be the presentation. And so when I store the values in the chi-square test, I can get different tables out, and we should have talked about this before, but like here's the observed data, and then here is the standardized residuals. So that when we run it, we get both those values, and we'll use those in just a second when we do the Mosaic plot. So the Mosaic plot, we just type Mosaic plot in. We need 3 things. So first thing is our contingency table, which is, we're going to start with the X tabs one first. So observation 1, and then we have to say that we want to shade, we want the shading to be true because we want the colors to be there. The colors help indicate, well, here, we'll just, what happens when we don't include this? Let's do the name. Pressing the wrong things. There we go. And so then when we run this, notice it's all kind of black and white. But when we do shade is true, it adds a little bit of color. And this is really helpful because this is giving us, you know how we have like our observed and our residuals table right here? We get both of those at the same time, like just rough estimates of them. So let's kind of talk about how like each one of these rolls into it. So we have the observed and the residuals. So notice that we have the different sizes and stuff like that. The idea is that the different sizes of the rectangles is the size of the observation, right? And so really it's all relative to and well, what we're saying by the observation, it's relative to the other thing. So notice that in the observation, the largest value is cats don't dance, and the smallest value is dogs don't dance. And so notice on our graph right here, the largest rectangle is cats that don't dance, and the smallest one is dogs that don't dance, right? So that's like how we can see the size indicates the observed value. Whether it's a solid line or a dotted line will indicate if it's more or less than expected. If it's less than expected, it's a dotted line. If it's more than expected, it's a solid line. Okay? So notice solid line here, it is more than expected. Solid line here, more than expected. Dotted line here, less than expected. Dotted line here, less than expected. Okay? Now, it's the thing is like we need to know if it is significantly less than expected. And that's, remember, what our standardized residuals come in, and that's like indicated from these colors. Sort of. The idea is like, remember when we talked about standardized residuals, we noted if they were significant if it was greater than 1.96, right? These indicate it by 2. So if they're colored, then they're definitely significant as far as we know. But for these ones right here, we're not as quite sure because it could be 1.97, and that would be good for us. Fortunately, when we look at the residuals, let's see, the 2 white ones are cats don't dance and do dance. So cats don't dance and do dance. They are both less than, or they're both less than the absolute value. Their absolute value is less than 1.96. There we go. I can speak. And And then just to kind of bring this around full circle so we can see the what the mosaic plot looks like with the other observation. Notice what happened. The labels of the axes went away. Now we can add these in if we wanted to, but it's just an immediate observation. That's just more arguments that we'd have to add to our function. So anyways, that's kind of it for the explanation of the mosaic plot. There is a couple other things that I want to point out. First of all is that there is no data for the lab. You're going to be saying what the code is that you would run the data. And then you're also given like the interpretation or the graph itself, so you have to interpret it. But you're not going to be given data to run the lab. Okay, I repeat, there is no data for this lab that you will be using. Just use the information that you're given from the lab and you'll be doing great. Anyways, I think that's good for today. Hopefully you found something useful. I wish you all the best of luck on the lab, and I will see you all next week. Bye. Hey everyone, I hope you enjoyed that video. If you did, please press the like button below. It lets me know I'm doing something right. If you have any questions about any of the content, please send a message in Canvas to both me and the rest of the teaching team, and we'll get back to you as soon as possible. If you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for when I post the next video. Anyways, I think that's good for this video. I'll see you all later. Bye!